Hi, welcome to the Unit 4 review. Just note, I can tell already this is going to be a long video. So again, just skip to the parts that you need or rewind and or skip back. There's technically no rewind here because it's like not that kind of video. It's not VHS. But yeah, so skip around, feel free. Or if you want to just see the answers, just skip to that part. Don't feel obligated to like watch the whole thing unless you want to, right? And we can just do it together. But my recommendation is that you do them first, or if you don't have a clue on how to do them, then I would like watch one problem and then see how to do it, and then do the other problems by yourself, and then unpause and then push play, and then watch the video and see. I would just check the answers, okay? Or if you want to hear the explanation, go for that as well. But my recommendation is not just sit there and watch and be like, oh yeah, great, Miss Lee knows how to do it. Yeah. You need to actually practice doing it. So make sure you do that. And again, if you don't have a printer, you don't need to print it out. You can just write on a separate sheet of paper. No worries. Or you can go on Canvas and then practice on Cami. Either way is okay. All right. So here we go. Number one, sketch the graph by making an input-output table. So we're going to just do an input-output table like this. And here's our X, here's our Y, and we're going to think, okay, we're just going to plug in some numbers. So I always like to think about what's the smallest number that X could be, right? And I know for radicals, we definitely have some X's that it can't be, right? So we can't like have a negative number here because the square root of a negative number, like 2, yeah, it's going to give us, it's not going to work out because that's imaginary. We can't graph imaginary on a real coordinate plane, right? So here we go. Let me try to use different colors. And so I'm like, okay, 0. I know definitely 0 is the smallest one because that's the smallest it can be. Can't be -1 or anything like that. And so here I'm plugging it in. On the test, do you need to show the work? You should at least show one. These kind of problems, it's kind of simple, so it's not too hard to show. But at least show one so that I can see, oh, this is what you're thinking. Because honestly, maybe you just like I don't know. So the square root of 0 is 0. And so we're going to put in the 0 for y, right? I need to just see your thought process. And then so I'm just going to plot as I go. For you, if you want to do all your input-output table first and then plot, go for it. But for me, I think this is easier just when I'm using different colors. And so another one, so I'm going to think, okay, so the square root of what will give me a nice number, right? So if I do like 5, right, that's not going to be good because what's the square root of 5? 2 point something, right? So you see how it's not nice? So think of perfect squares, right? I'm like, oh, 1 times 1 is 1. So let's do that. So the square root of 1 is 1. So when I put in a 1, I get a 1. And so you're like, how many points do you need? I would say enough so that you could see what the graph would look like. If I just do 2 points like this and I just stop it, you're like, oh, it could be a line, right? We're like, oh yeah, straight line like that. Oh, all right. So we definitely need more than 2. I would say as many as you can. I would say maybe at least 3 or 4 if you can. Find them. And then so another one is we can't use 2 because the square root of 2 is, again, not a perfect square. So the square root of 3, no, 3 doesn't work. Square root of 4 works. So the square root of 4 is equal to just 2. So when I put in a 4 for x, y is equal to 2. So here's 4, 2, just like that. And technically there are no other ones, but we're just going to go one more because I know that the square root of 9, which I know we can't graph on here, but it's close enough where we could just kind of add them in, right? So the square root of 9 is equal to 3. So I'm just going to 9, and that's going to be about right there. So my graph is going to be, so remember, it's not a straight line, so it's a curve. So I'm going to kind of have it go through all those points. Make sure you add in the arrow to show, yes, continues on forever and ever. Don't put it here because it does not continue on forever. It just stops there, remember? Because it can't be negative, right? X will never go to the negative side. It's always positive. I would like to meet those kinds of people, radical people. All right, so here we need to do the domain and range. So remember, domain is talking about the X and the range is talking about the Y. Let me use this darker purple. Okay, so the domain, if you look at, so how far to the left can it go, right? How far to the left and how far to the right, right? That's talking about. So remember, we have a starting point here, and it can go all the way this way, right? So we can use any of these numbers and so on and so forth, all the way to infinity, right? So it's going to go from 0 to infinity. And remember, the square bracket means that it includes 0. It includes 0. Yeah, because if we put in a parentheses, that means it cannot equal 0, but anything right after that, it can totally equal. So, but here we like literally we have a point at 0, 0. Yeah, x can equal 0. So we're good with that. If you want to, because I notice usually for graphs, sometimes it's easier to just write it as inequalities. So if you want to write, oh, x is greater than equal to 0, that's totally fine. Okay, either way is okay. You just don't need to do both. I've had some people who did both. Like, that's unnecessary. Just do one. Because then if you do one, if you do both of them, but you mess up on one of them, I'm like, I can't give you like full credit. So I'm just saying, play the game. All right. So either way is okay. And let's take a look at the range. Well, how high can this go and how low can it go? Well, the graph goes up until 0 and it's anything positive, right? So it's going to be from 0 to positive infinity. Looks very much like the domain, right? Except we're talking about the y, right? And again, if you're writing in inequalities, you just can't write x, right? That's the one little thing that you got to remember. You have to put y is greater than or equal to 0. That's it. All right, moving on to the next one. So now let's graph this guy. Let's go here. So this is going to be the cube root of x. Now, and if you don't know your cube roots very well, just think, remember, you're multiplying the same number 3 times, right? So maybe sometimes it's easier to do the y first, right? Because we know that if their answer is going to be, well, an easy one is just 0, right? 0, you plug it in. So the cube root of 0 is 0, right? Because 0 3 times is still 0, right? So here we go. That's the first one. And then the second one, I think, okay, well, if I want it to equal 1, right? Well, what would be the cube root? It's just 1 times 1 times 1, which is just 1, right? Maybe that's an easier way to think about it if you think about it backwards, right? So if the y is 1, x has to be 1, right? Which we could also say, remember, since it's cube root, we could also say the -1, right? So if y is equal to -1, what is the cube root of that? -1, because -1 times -1 times -1 is -1, right? So there we go. And again, if you were to stop right here, that would be bad days, because what does it look like? It totally looks like a straight line. That's what it looks like. And so, okay, we're going to need more than 3 points here, because we know it's not a straight line. That would be called linear. This definitely does not look linear because it's a cubic, right? So let's do some more points here. So that's what I'm saying. You can't just restrict yourself. Oh, well, I got 3 points. That doesn't mean anything, because if we did that here, we'd be like, oh, it's a straight line. Okay, so let's try another one. Let's try, well, what if x was equal to, or the result, the y is equal to 2? Well, 2 times 2 times 2. 2 times 2 is 4. 4 times 2 is 8. So the cube root of 8 is 2. I'm like reverse doing it, so I don't have to think about it too hard. So here, so when y is equal to 2, x is equal to 8. We're going to go 8, 2. Do you see? Not linear, right? But if we know the positive one, we know that there's a -1, right? So if y is equal to -2, we know that the cube root has to be -8, right? Because -8 times -8 times -8 is -2 times -2 times -2 is -8. All right, so that's going to be right here. So -8 and -2. It's going to be right here. So we're going to just graph this guy. So we know it's going to look something like, and it turns, oh shoot, that's like a terrible. So honestly, if you want to go in Desmos and see like a better version of this, oh, that was not bad at all. Could be better, but oh, can't forget my other arrow. Do a little bit of erasing here so that doesn't look so bad. All right, so something like this. Hopefully your graph will be better than mine. All right, there we go. There's our cubic, not cubic, it's a cube root function. Notice there were no restrictions right here, right? Remember we had to do that for this one. So we're going to go with that. And domain and range. So notice for the domain, right? As you can see, X is pointing both left and right, which means, yeah, X can be all real numbers. So we're going to say from negative infinity to positive infinity. And so you're like, well, what if we want to do with the inequalities? We'll just say, you could just say all real numbers. That's it. Okay. And so for the range, excuse me. They always come in pairs. I don't know why they do that for me. But with the range, so again, notice it's going slightly up and slightly down, right? So it's going to go on forever and ever. And notice if X could be anything, literally Y could be anything, right? Because it could be any negative number, any positive number. It really, we can find them all. So it's going to be from negative infinity to positive infinity. And that's going to be true for most cubics, or cube, I keep on saying that, cube roots, right? It's only the ones that are square roots or the, what is it called? Fourth roots, those are the ones that are restricted, right? So those are the ones that have these limitations, like, oh, it only goes up until here and it can't do the other stuff, right? So again, so this will be, we would just call this all real numbers. Honestly, if you didn't remember that, and you're like, oh, I know it's something like this, is X is, or it's range, right? So it's Y less than positive or a positive infinity. Yeah, that's totally fine too. Either way is okay. You just have to remember that you can't put equal to. That's why we put these not parentheses, or that we just put these parentheses here, because it cannot equal negative infinity. Remember that, right? Been saying that forever and a day. All right, so let's try number 3. All right, so here we go. I'm gonna write a little bit small, so you may have to zoom in. So again, notice that the square root is not inside the X. Nope. That makes no sense. The square root does not include the -3 or the -3, right? So that's going to be different here. So what we're going to do is we're going to just, again, pick some numbers for X. And this is the square root of X, exact same numbers as what we did when it's just the square root of X and no -3, because the -3 does not affect what's inside the square root, right? Because it's not part of the inside. So let's just do that. If you look right here, this is going to be 0, 1, 4, and 9. I'm just taking the same numbers that we did before because those were our perfect squares. So if we plug in 0, so Y is equal to square root of 0 minus 3. Well, square root of 0 is 0 minus 3, which is just -3. Okay, and so we're going to go 0, -3. See that? And then we're going to go to the next one. So this is going to be 1. So Y is equal to the cube root of, or square root of 1 minus 3. Well, square root of 1 is 1 minus 3, which is going to be -2. So it's going to be right here. All right, next one. That's going to be 4. So I'm going to just write this over here. So Y is equal to the square root of 4 minus 3. And the square root of 4 is 2. 2 minus 3 is -1. So this is going to be -1. 4 negative. So if you notice here, literally all we're doing is taking these Y's and we're just subtracting 3 from it, right? Which makes sense because we're just taking the square root or square root of X and subtracting 3 from all the answers, right? So literally it's just all shifted down. We're just bringing everything down. And the last one right here is going to be 9. So the square root of 9 is -3. So it's going to be 3 minus 3, which is just going to be 0. So, ooh, kind of, there's my 9 right there. That's the 9, 0. And our graph is going to just look like that. All right. And our domain and range, I'm just going to put them in this color. So domain is going to be smallest X, so furthest left. We're not talking about how low or how high. How left can it go? It goes up to 0. So 0 all the way to positive infinity. Okay, so that's, we're looking from here to on. And if we're looking at the, what is it called? The range, well, how low can it go? So that's from this -3 all the way up, because see how it's tilted up? So it's going to be from negative, -3. Can it equal -3? Yes, it includes -3. So we're putting in the square bracket all the way up to positive. All right, do you see the difference here? All right, for number 4, what I'm going to do, okay, so pay attention, because this is for, I'm going to just do this with this being over. So this is going to be square root over the whole thing. Okay, I'm going to change this problem a little bit just so that you can see, because if I just did it without, it's just, you basically add 5 to all these guys. So literally what's going to happen here is just going to shift up 5. Okay, that's pretty much it. So let's see what happens if it's the 5 is inside the square root. Okay, so what would happen there? Let's try the input-output table. All right, so y is equal to. Now, if we put in, okay, so normally remember we put in 0, right? But we're gonna think ahead. Okay, we're gonna try to problem solve this. If I put 0 plus 5, right? 0 plus 5, excuse me, 0 plus 5 is 5. That's not going to help us, right? Because what's this? I mean, we can use the square root of 5. We can use our calculator and figure out what the square root of 5 is, right? It's like 2 point something, right? But I want to use nice numbers, right? Because I want to graph with nice points, right? Integers, right? So what we're going to do is, well, how can I make this be a 0, right? Because remember, we always started with a 0. That would be our smallest number. So what number does this have to be so that it'll equal 0? Right? And you're like, oh, -5, right? Because -5 plus 5 would be 0. And the square root of 0 we know is 0, right? So -5, 0. There we go. So x is going to be -5, 0. Ooh, do you notice it moved 5 to the left? Coincidence? And usually in math, no coincidences. There's usually a reason for that. Okay, now let's try the next one. So let's do some reverse thinking here. So I know I have this plus 5, and what if I wanted to equal 1? So I want this to be the square root of 1, right? So what would this have to be? Well, I need to take 4 away from 5. How do I do that? Oh, just go -4, right? So -4 plus 5 is the square root of 1, which is equal to 1. Okay, so if x equal to -4, that means the y is going to equal 1, right? Because -4 plus 5 is 1. The square root of 1 is 1. There we go. All right, so we're going to plot that in here. So -4, 1. You see how it looks like we're starting out exactly the same. We're like, okay, here's a point, and then we go to the right one, up 1, and we get to another point on the graph, right? And so I'm going to say, well, maybe we could predict this. So here, from this green point, the starting point, we go to the right 4 and up 2, and that's another point on the line. So let's predict this. Let's see if it's true. So if we go from this original point, we go to the right 4, 1, 2, 3, 4, up 2. We're predicting that that's where it should be. Let's find out. All right, so the next one, we said we wanted to equal 2, right? So what plus 5 will give, because we want it to be 4, so it's the square root of 2. The square root of 4 is 2. So we're like -1, right? Because -1 plus 5 is what? 4. What's the square root of 4? 2. Yay, happy days, right? So then we're going to put that in there. So we put in -1. So x is -1, y is 2. And we'll look at what? -1, +2. That's what we just said. So do you see? We could totally do this. And then one more. And so we want this to equal 3. So y is equal to something plus 5 is equal to 3. So we know that the square root of 9. So this whole thing has to be squared. The inside has to be 9, right? Because the square root of 9 is 3, right? So this thing has to equal 9, right? Because it's under the square root. And so what does it have to be? 5 plus what? 5 plus 4, right? And so that's going to give us that square root of 9, which is equal to 3. So here we go. So x's has to be 4 in order for y to be 3. So here we go. We're going to go 4, 3, just like that. All right, and then we're going to draw in our line. Boom. All right, and notice for our domain and range. So domain, how far left do we go? We go as far as -5. So it's going to be from -5 all the way to positive infinity. So from here on up, or here to the right. And then for our range, we're going to say, well, how low does this go? Well, it still is at 0. That's the lowest it goes. Then it goes all the way up, right? So it's going to be from 0 to infinity, just like that. All right. So those are those problems. The next ones are going to be, are they inverses of each other? Okay. Kind of regretting having this many problems, but yeah, skip through, kind of figure out which one you need help on and then go from that, or chunk the video. It is up to you. All right. And we're just going to put them all in one. All right, so here we go. So state if the given functions are inverses. And the way we show that functions are inverses is if we put one function inside the other function and see if all the operations cancel each other out, right? Because that's what inverses should do. And so what you should have left is just x, because all the other operations canceled out. Okay, so a good way for me to show you that is if I show you one that's actually an inverse. So we're going to start with 6 first, okay, and then we're going to go on to 5. All right, so the first step is we want to, let me actually go a little bit larger so you can see they're on the screen a little bit. So number 6, it's going to be, we'll just try this. And honestly, it doesn't matter which way you do first, but I'm just going to go h of f of x. So we're going to put in the f of x function inside of h of x. Think of it like, like one of those, those, the Russian dolls where they have a doll inside a doll, like kind of thing. So we're putting f of x inside of h. Okay. That's literally what we're doing. And so what I like to do is I like to think of, okay, we want the framework here. So what is this outside doll looking like? Well, it's going to be -8 minus. So instead of this x, we're going to put in whatever this f of x is. Right? And then we have this divide by 4. So note right here that all of this is right here. Like that's this part right here. So hopefully, so then what you have left is this x part right here, which is this part right here. Okay, does that make sense? So inside of this 8x, we're not going to put an x. We're going to take that out. And we're putting in what? The f of x, which is just the -4x minus 8. Why are we putting this in? Because that's what f of x is equal to. So there we go. So we're going to use that pink color. So it's going to be -4x minus 8. All right. So now let's take a look here. We're just going to do some order of operations. We're going to see, we're just trying to simplify the side. And if I notice, I always deal with the parentheses first. And so I'm like, ooh, outside the parentheses is minus. I need to deal with that. So we're going to distribute this minus to both of them, not the -8 or the -8. That's not part of this. So I'm going to copy this down and then I'm going to be like, okay, so this is negative. Ooh, I usually like to work below. So let's go below. So it's going to be -8. So negative times a negative is a positive. And then negative times a negative is a, oh, I should probably write down the other stuff, 4x. Negative times this negative is a positive 8. And I know that this is a minus, but it's just easier for me to say negative times negative. And then on the bottom is still my 4. Okay. Now we're going to have to deal with the stuff on top because, they go together. So we're going to be like, can I add anything together, combine like terms? And I'm like, yes. Oh, I totally missed that. -8 plus 8 is what? 0. Yay. See how they cancel out? And then what do we have left? Because it's just, if it's 0, we don't have to write that, right? Because it just canceled out. So then what do we have is just this 4x over 4. Well, what's 4x over 4? And you're like, oh, I could cancel out the 4s. And why can we cancel out the 4s? Because 4 divided by 4 is 1. You're like, well, last time it was 0. And that's because we were adding. But this time we're dividing. So that's equal to 1. And why do we say it's canceled out? Because 1 times x is x. All right, so here we go. So this is just equal to x. Okay, so far it looks like this is an inverse. We have to check the other way though. If you have one side being x, we need to check the other part, okay? Not just to check, but it needs to be true for both, like either way you put them in. It should not matter, right? And I'll say like 95% of the time, it'll work out. But there's a few instances where like it'll work one way, but not the other way. I'm just saying. Okay, so know that to be true. I'm going to try and use the same colors here. So now we're going to put f of x and then h of x inside of it. And go the other way. All right, and so we're going to just set up the frame of it. Okay, so what is f of x? F of x is -4. And then we have this parentheses. That's where our x is, -8. Okay, so if I am, I'll just use the green. So this is going to be like that -4, -8. And then this is going to be the inside. Hopefully my colors are not going to be too confusing. Well, we'll do the best that we can. And so in the inside there, we're going to put in h of x, which is this -8 minus x over 4. And now I really can't see that very well. So I'm assuming that you can't see that very well. So let's try this out. Just erase it. There we go. So that should be better. So now if you take a look at this, you're like, well, what do I do? Okay. I'm always, because remember, these are supposed to be inverses. So they should be canceling out. So I'm looking for things that can cancel out, right? And I'm like, oh, well, there's a 4 here and a 4 there, right? A 4 on top and 4 on the bottom, which means it's 4 divided by 4, just like how we did here. We could cancel that out, right? Because that would just be 1. And I'll show you the other way, because some people were just like multiplying it out. It doesn't matter. Like, let's say you didn't recognize that. You're like, oh, I didn't know that. I just distributed the -4. That's fine. All right. And so what I'm going to do here is I'm going to distribute this negative. And so what you get is negative times -8 is +8. Negative times -x is plus x. And then we have that -8 out here, right? And so then right from here, I'm like, oh, the 8's cancel out. Happy days. Because they're just 0. And all we have left is the x. Yay. So we can say, yes, they are inverses. All right. And so I'm going to show you again. So in the alternate reality where, like, let's say you really did, what is it called? You really did multiply them out. So this is what it would look like. So -4 times -8, which would be 32. Or actually, this is -4 times -x, which would be plus 4x. Divide that by 4. Remember, you're not distributing the -4 to the bottom, because if you do, then you're basically, so if you're multiplying the bottom by -4 as well, you're just -4 divided by -4 is 1. You're essentially just multiplying by 1, and you're not changing the values. You just didn't multiply it by -4. You're busted. You can't do that, right? So make sure, remember, this is like over 1. So if you are going to forget that, I would put that over 1 and go 1 times 4, which would still be 4. All right. And don't forget our -8 out here on the outside. And we're like, okay, we got this divide, right? So we got to divide both of them in. So 32 divided by 4 is 8, plus 4x divided by 4, which is x, -8. So notice, oh yeah, we got back to what we did before, right? It's exactly the same thing. And we would still get x. Please note that you would not combine the 32 and the -8 together, because this is technically not 32. It's 32 over 4. So you would have to get common denominators to even think about adding those two together. All right. So do a little bit of erasing. There we go. All right. So that's what it means to be an inverse, right? Either way is okay, kind of thing, right? And so now here, let's try this out. And honestly, if you take a look at it, you're like, oh yeah, that's not an inverse, because this is a 5th root. If you're trying to undo like these operations, how is a cube gonna get rid of a 5th root? Yeah, that's not gonna happen, right? But we're just gonna show that, right? So even on the test, if you're like, yeah, that's not inverses, I already know. I want you to show me algebraically, because I want to know if can you do this? Can you do this composite function thing? That's something that I'm trying to see if you can do. So please show me that, right? Even though you're like, yeah, I know that that's not going to be. So at least show me one side. So here we go. We're going to try g of f of x. And honestly, you can try either way. And if you really want to see the other way, then just let me know. Email me, and then I can just do that for you. Okay, so we're going to set up the framework. and this is going to be our g. So this is going to be the square root of, or square root, fifth root minus, and here's my x now, plus 2. I'm going to extend my radical because the 2 is inside the radical. And instead of x, what are we putting in? F of x. So that's going to be negative x cubed plus 1. Please note that the negative on the outside here has nothing to do with the negative in the inside, because this is part of the f of x, right? All right, so now we're going to just simplify. So we're like, ooh, the negative and this, we're going to distribute this negative. So we got the fifth root again. And I'm going to distribute the negative. So negative times negative is positive x cubed. Negative times plus 1 is going to be negative 1. And then we have this plus 2 on the outside there. Notice we don't have any more parentheses because we already used it. Right? We already did the distributing. No need for it. So I can combine like terms. I go fifth root of x cubed plus 1. And this is like, okay, there's nothing more for me to simplify. This is pretty much as simplified as it's going to get. So we're like, okay, yeah, that's it. So that's definitely not just x. We still have some operations to go. They didn't cancel each other out. So we're like, no, they are not inverses. This should probably be like a capital N. Do you need to do the other side? No need, because even if the other side did all simplify to x, which it wouldn't matter because it needs to work both ways, just like how it did here. And again, remember, it has to equal x, not 2x, not 3x. And somebody had asked, it was a good question. What if these answers were both exactly the same? Would that still be, would that work? My question is, do they simplify down to x? No, so therefore it wouldn't work. So if this was like an x plus 1, and this also ended up being like an x plus 1, are the inverses? No, because they're not just x. We still have operations left that didn't get canceled out. So that is a no-go, but that was a very good question. All right. I should probably speed this up just a little bit, but hopefully these are helping you out. So let's try these out. So I'm going to try f of g of n. And I'm going to go a little bit faster on these because I've already done a lot of the explaining. I'm just going to show the work so that you can kind of see, oh yeah, this is how I set it up. I would, again, recommend that you set them up first, try them out, and then go. Or if you're like, I don't want to go too far, like what if I'm wrong? Then just set it up first, see my equation, see if it's true, and then you go on. And if you feel like I made a mistake, which is very possible because I too am human, email me, and so that I could be like, oh shoot, yeah, I said that wrong, or whatever it is. All right, so let's try this out. So I'm going to write the fifth root of whatever this n is plus 1. Include that in the radical. And I'm going to put in, so I'm just going to do a think aloud. This is what I'm thinking in my brain. All right, and then I'm going to put in my g of n, which is 2n to the 5th power. And then I am going to, okay, technically I don't need these parentheses because there's nothing outside here. So I'm just going to write the 5th root of 2n to the 5th plus 1. Okay, like I would like to cancel out the 5th root and the 5, but I can't because of this 2 and the 1. Like there's like, I still have the 1 here, it doesn't cancel out. So this is all I have, right? So I would say, yeah, this does not simplify down. No, they're not inverses. All right, number 8. Let's use some different colors here. So let's try here, f of h of x. Actually, I'll not use green because I have green on that one. I'll use blue, h of x. So the colors don't get mixed up. So that's going to be, f of x is going to be 3 plus, okay, I got my parentheses. Okay, now I'm going to have my parentheses in the parentheses because I have the x there, minus 1 cubed. All right. And then inside that x, n is going to be blue, and is going to be h of x, which is going to be my cube root of x minus 3 plus 1. And notice the plus 1 is outside of the cube root. I try to make it like that. I guess technically we did not need these extra parentheses because there's nothing outside of the x that we need to like multiply or whatever. So I guess that was kind of superfluous. But so I'm just going to rewrite it without that. So cube root of x minus 3 plus 1. This is going to be minus 1 cubed. All right. And now I'm going to start doing my favorite part, which is canceling stuff out. And I'm like, okay, well, this is plus 1 minus 1. So that's definitely cancel outable. So what I'm going to have left is 3 plus cube root of x minus 3, which n to the power of 3. And I'm like, ooh, cube root, cube, cancels out. Yay. We don't need those parentheses anymore. So we're just going to have 3 plus x minus 3. Ooh, the 3's cancel out. So all I have left is x, my favorite part. I really enjoy canceling things out. It just makes me really happy. If ever I can do it, I will do it. So let's do this. So h of f of x. Now, I got this to be simplified down to x. We just got to check the other way, right? So we got to reverse it, right? So instead of h of f of x or f of h of x, we have to do h of f of x. You know what I mean? Got to flip them. That's what I meant. Long day today, I guess. So h is the cube root of, I have this x here, so I'm going to put some parentheses. Well, technically, I don't need the parentheses, but kind of helps me to see it. Minus 3. Again, that's inside the square root. And then plus 1. And that's outside of the square root. So, yeah. And then I'm going to put inside there f of x, which is 3 plus x minus 1 cubed. A lot of parentheses going on in here, but I think we can handle it. And here we have, well, in the inside, okay, we don't need these parentheses in here because there's nothing outside there that we need to distribute. So it's just going to be, I'm going to just drop them. So 3 plus x minus 1 cubed minus 3. Again, that's inside inside the radical, and then the plus 1 on the outside. These better cancel out. And if you notice, ooh, yes, 3 and minus 3 cancels out. And so I'm going to have cube root of x minus 1 cubed. And I have this plus 1 on the outside. And I'm like, ooh, yes. And now we have just the cube and the cube root. So I can cancel those out. And I'm going to have x minus 1 plus 1. Now the x minus 1 plus 1 cancel out. So all I have left is the x. Happy days. So I have, well, don't just stop there and be like, yeah, I'm done. I almost did that. So we have to answer the question. Yes, they are inverses. Right, you got to make that conclusion, right? You could just do all that and be like, okay. And I'm like, so what? What does that mean? Sad days. You don't want that. All right, let's try this out. So we'll do f of h of n. Let's see if this works. I'm thinking probably not because, you know, what's going to cancel out this minus 9? But we'll see. I mean, honestly, if it's not inverses, then, you know, that makes less work for us, right? So here it is. F is going to be negative 3. And I got my parenthesis, this is my n, minus 9. And then my green color, which is h of n. So it's negative 3 minus 1/3 n. All right, so it looks like I do, a good thing I have the parentheses there because I do need to distribute that. So that's going to be, ooh, maybe I'm wrong. So negative 3 times negative 3, which is positive 9. There we go. And negative 3 times negative 1/3 is positive, well, the 3's are going to cancel out. So there's just positive n. And then we got that minus 9 out there. Ooh, look, n's are going to cancel out. So all we have left is n. So this is good. All right. And so maybe some of you guys are like, well, that's not an n. It's not an x, it's an n. It doesn't matter. It's just whatever the variable is. Okay. In case if we have some literal people here. Some people are literal. That's okay. So f of, so now let's try the other way. Since it worked for one way, so we've got to try the other way. And most likely it will work, but you know, just in case. I totally did this wrong. Let me try this again. Oh, draw. I'm gonna go h. So h of, and which is this color? Okay, this is f of n. So let's try this out. So I'm going to write this right below here. So h is -3 minus 1/3 times whatever n is. Inside that n is going to be f of n, which is going to be -3n minus 9. All right, now I'm going to distribute just the -3, 1/3, right? So that's going to be -3 out here because that has nothing to do with it. -1/3 times -3 is positive n, right? Because 3 divided by 3, 1. And -1/3 times -9 is going to be +3. Again, what? And so I get n. So this is going to be yes. They are inverses. All right, last one of the inverses. We're only on problem 10. When am I going to get to 40 whatever? I don't even know. How long is this video going to be? Oh, what was I thinking? All right, let's keep on going. All right, so here we go. G of n. G of f of n, or g of f of x. They're all in a blur now. I don't even know what I'm doing anymore. All right, so g is going to be my x. Okay, this really doesn't look like it's going to work. Like really, x plus 4, and then here we have all these other numbers. Yeah, I don't think so. But we'll do it anyways. And then so here we go. We're going to put in 2x plus 4 over 5. We'll humor them. All right, so let's try this out. Okay, I technically don't need these parentheses because there's nothing outside here. So it's just going to be 2x plus 4 over 5 plus 4. Yeah, that's it. Nothing cancels out. I'm not even going to try and make these common denominators. It doesn't even matter because I know it's not going to, like, they're all pluses, there are no negatives, right? So yeah, I would say no. They are not. So I would just stop like right here. Not inverses. You don't even need to check the other one. Don't even need to do it. All right. So now we're back. We're now in the next section. Yay. Whew, those are time consuming, but fun. Always fun. All right. So we're going to find the inverse. Now, we just have one equation. We're just finding the inverse. It's kind of like what we did for lesson 2, or no, lesson 5, day 2, like where we're solving for the different equations or different variables. It's the same idea. And so if you remember, we had steps for these. I forgot which lesson. I think lesson 2, probably. I don't know which day, but probably lesson 2. But let's try this out. So here we have g of n. Remember, we're just going to replace it with, we're going to take it out of function notation. So we're going to just say that g of n is equal to y, okay? Because usually there's a y there. You know, we use x and y, okay? So you don't have to state that. If you just change it to y, I already know that. So and once you, if you just, yeah, so we're just gonna just change it to not function notation because we want to just do a little bit of manipulations here. Y is equal to cube root of n plus 1 minus 2. Now all we're gonna do, remember inverses, we're just flipping them, right? So what we're gonna do here, I can do this. So what we're gonna do is we're gonna just switch the n and the y. All right, so here's the n, and we're gonna replace it with the y. So remember, this is like what I talked about Freaky Friday, right? Freaky Friday, where if you have not seen the movie, the long time ago movie, they literally just, the mom and the daughter are like at odds with each other. They're always fighting, and then they literally like switch places, and then they get to see like the other, like, ooh, same thing. Okay, so now the y gets to see what the n is doing, the n gets to see what y is doing. Okay, and so now all we're gonna do is we're gonna solve for y. Okay, what is that going to look like? So here we go. We got y here on the right-hand side, and we want to get rid of all this other stuff. We just use the algebra that we've been doing, right? Solving for x kind of type of thing, right? Same thing. So here, I'm going to get rid of the -2 first. So I'm going to add 2 to both sides. And I know, and you know that I know, and I know that you know that n plus 2, we can't add that. So it's just n plus 2. So here's n plus 2. Is equal to the cube root of y plus 1. Now remember, the cube root is by itself, so we can cube them. Now we can cube them. So remember to put in their parentheses and cube it. All right, and we're going to put this right up here. So this is going to be n plus 2 cubed is equal to, now the cube root and the cube cancel out, right? They're inverses of each other. So all we have left is y plus 1. then what do we have left? The plus 1. We got to get rid of that. So subtract 1 on both sides. And what we're going to do is, this is just going to be, we can't, the 2 and the 1 cannot combine. They're not like, you can't do that because they are like terms, but we can't combine them because this is not just 2, it's 2 to the 3rd power. So we're just going to leave that. So it's just going to be n plus 2. We're not opening up that bag of worms, minus 1. Can you multiply this all out? You can. Do you have to? No, just leave it like that. All right, and this is equal to y. And the last step is we're going to return it back to function notation. Okay, and so if we were to say, oh, it's g of n is equal to n plus 2 cubed minus 1. If we did it that way, then we could get confused. We're like, well, didn't we say that g of n was the cube root of n plus 1 minus 2? Why are we saying it here? I'm like, oh, this is just the inverse. And the way we say, oh, this is just an inverse is put the -1 right there, which shows, oh, this is just the inverse of g of n. And how do you say that? We just say inverse of g of n. That's how you say that. You would not say g -1 of n. I mean, you do, some people still do, because that's literally what you write, but it's definitely not to the power of, it looks like exponent, but it's not an exponent. Okay, it's just show you, oh, this is the inverse of g of n. This is just function notation. Okay. All right. Why they place it up there, they just did. Okay. That was just a matter of somebody saying, okay, we're just going to put it up here. Okay, they could have put it down here, but usually that's meant for something else. So we'll just leave it at that. All right. There we go. And so let's try this again. Again, I'm going to just do a think aloud. I'm going to try and go through these a little bit faster, just for you. Or maybe just, I don't know. Okay, so here we go. So I know f of x is just y. So y is equal to x minus 1 cubed. And now I'm going to do Freaky Friday. And okay, that sounds weird. And it's going to be x equals to, I feel like lightning needs to strike or something, 3. And then, why did I, oh, anyways, that's okay. So I just have the cube there. I want to get rid of that. So I'm just going to be like, oh, let's just cube root it then. Cube root. And all I have left is now the cube root of x, which is equal to y minus 1. And then I'm going to add 1 to both sides. And what do I have left is y is equal to, I'm just moving the y to the left-hand side because I like it on the left instead of the right. The cube root of x plus 1. Now I'm just changing it to function notation. So it's going to be the inverse of x is equal to the cube root of, not 3, of x plus 1. There we go. That's my inverse. Just like that. All right. Let's see here. Now we're going to do this particular, so this is different. These are different problems than in the original packet, the review packet. I don't know what I was thinking. I was just like quickly trying to do them, I guess. And so I know that 13, I think it was 13, that had the x on the bottom. Those are rational functions, and we'll talk about them in another unit. But we're not dealing with that now. That's not part of the thing that we're testing. So no worries. So you can just X those out and copy these problems in, because these are, you should know how to do these, right? Because these are just linear. So again, we're going to just do this. So sorry about that, my bad. So negative 2x minus 10 over 9. So we change the y, and then we're going to just Freaky Friday. So this is going to be x is equal to negative 2y minus 10 over 9. All right, now let's just solve. So I got to get rid of that 9. So I'm going to just multiply by 9, because since it's get rid of the divide. And then we have left 9x is equal to negative 2y minus 10. I got to get rid of that 10. Got to get rid of add and subtract first, right? We couldn't do that here because we had this whole big divide thing going on. So now that it's just back to like one line. And this is going to be 9x plus 10 is equal to negative 2y. And how to get rid of that negative 2? DVD, divide by negative 2. And this is just going to be y is equal to 9x plus 10 over negative 2. Now, if you choose to divide the 9 out, you can, right? So this could be y is equal to negative 9 over 2x minus 5 is, looks like slope-intercept form, right? You remember that from Algebra 1. or you can just leave it like this. I would only say, usually we don't leave the negatives on the bottom. So I would say, please make sure you bring the negative to the top. So you just have to distribute the negative all the way across. So it makes everything on top opposite, right? So that's going to be over 2. Either way is okay. We just need to make sure that we put this back in function notation. So that's going to be f inverse of f of x, which is equal to negative 9x minus 10 over 2. That would be it. If you wrote it like this, that is fine as well. Either way is okay. All right. And the last one of this section is going to be, so y is equal to negative 2x plus 5. Switch them. X is equal to negative 2y plus 5. And then we're going to subtract 5. And we have left x minus 5 is equal to negative 2y. How do we get rid of that negative 2? Divide it by negative 2. And oh, we have another negative again. Gotta deal with that. All right, so we get y is equal to, I'm going to just move that negative to the top. So it's going to be negative x plus 5, right? Because the negative gets distributed to everything on the top, over 2. All right. And so this is just going to be f inverse of f of x is equal to negative x plus 5 over 2. Please make sure you put it back in function notation. If it starts off as function notation, then put it back in function notation. And usually inverses are written as function notations, right? In that way, because we can, like, how are you going to show that it's an inverse with just y? Like you can't. So because if we put to the negative 1 power, then that looks like an exponent, right? But if it's in this form, in the function notation form, we know, oh, that's not an exponent. That's just function notation, right? All right. Number 15. These should go a little faster. Okay, so in our books, we had written down way back in the day, not too far back, but in the day, this one right here. So we had our radical, and there, remember that number right there was an index, and we have our exponent, okay? And so in order to change that to exponential form, we would, remember we said that that was the same thing as the exponent over the index, right? And the whole reason, well, why is that? You know, that's all in your book that we talked about. We're not going to get into that right now. You can algebraically, you know, prove that, but again, not going to do it right now. Oh, I'm going to think of it like this. I'm going to make some little. So remember, the exponent is the power, and power is like, where do we get our power from? The sun. So that's why it's up here on the top. Okay, we'll work on that drawing. And if you notice right here, I'm going to use a different color, like, I don't have brown. Okay, I mean, define brown. Brown should be here somewhere. If you were brown, oh, this is brownish, right? Brown. Okay, so index is, remember, the root. And think of like trees. Where are the roots in trees? They are under the ground. Okay, I can't show the ground. So this part right here, that failed, is under the ground, right? It's under the fraction, right? It's on the bottom of the fraction. So that's going to be there. Yeah, I tried. All right. So here we go. So this is, the one on the left is, this is called radical form. You know why? Because there's radicals in there. And this one is called exponential form. You know why? Because there's exponents in there. There we go. Very easy reason, right? So if we're looking for, so here we have it in radical. We want to change it to exponential form. There are literally no calculations. You're just changing the way it looks. That's literally it. We brought this in because, you know, SBA, which is a thing this year, does stuff like this. And it's good for you to know that, you know, just a hint right there. All right. So if we, okay, we're not going to take a look at the 15 and 16 just yet. We'll start off with 17. All right, if you take a look at 17, we're just gonna, okay, so we got our R. So that's anything that's inside the radical, which is just K. And our exponent is 2 over 5, right? Because 5 is the root. There you go, just like that. That's all you need to do. If you take a look at 18, right, we go 10a, that's the inside. And notice there's no exponent, which means it's the exponent of 1, right? 1 over 3, because our index is 3. Now, if you left it like this would be wrong, because literally what this means is just 10 cube root of a. Notice that the cube root only goes to the a and not to the 10. And so how do we make it include the 10 in there? You got to put parentheses, right? So you got to make sure you remember, you got to put the parentheses so that we can include the 10 as well, right? Because that's supposed to all go inside the radical. So there we go. All right, so now let's take a look at these. You're like, what in the world? Remember, if it's on the denominator, right, and we want to flip it back up, it needs that's a negative, right? So that's going to be, so we're going to do the exact same thing. So it's going to be 4 p's the r, right? We want to include everything in there, so we've got our parentheses. What is our exponent? 5. What is our root? 3. Now remember, this is in the denominator instead of in the numerator, so we're just going to put a negative right there. That's what indicates that. It's that simple. All right, same thing here, 6b. Got to put parentheses around that, and my power is 3. And there's nothing there. What number is it? Remember, it's a 2, square root 2. And notice it's in the denominator, so we're just going to pop in that negative right there. Done. All right. And that's how you do those. Now, if we want, now we're going to go the other direction. We got the exponential form. We want to change to radicals. Let's try. Oh, I probably need that. Well, you probably, I don't know. I'm okay. All right, so let's try this one. So I'm going to just put in my radical here. And I know that it is 2r. Right? And the root is 6. So it's the 6th root. And my exponent is 1. So I'm just going to leave it like that. You don't, I know that you know that it's 1. Like, we don't need it. We're professional, right? So we don't need to put that in there. Okay, so we're good. That's your answer. So the next one, again, please pause, do it yourself, and then check. Yeah, nobody wants to listen to my voice for, I don't know, I think this is going to be a 90-minute video. I honestly think that. I don't know, though. We'll find out. So here goes. So here's 5x. We got our radical, and it's the third root, cube root, and our power is 2, right? So I want to include all of this, so I'm going to put parentheses and put 2 just like that, right? If you want to put it around the whole thing and then put 2 on the outside, I think that's what our the answer key says. It's okay, either way is fine. And then, but we have the negative, so what you do? Now it's now it's in the denominator, right? Done. It's just a really big fraction, right? But that's how you do that. Okay. Don't think of it too complicatedly. And then for the next one right here, again, we got our radical, and it is a square. It's a square root because it's a 2 on the bottom. So you don't need to write the 2. I know that you know that it's a 2, so it's fine, right? So don't feel like, oh, Miss Lee might not know that I think it's 2, or that I know it's a 2. And so if you really want to write it in, go for it, but you don't have to. I assume that. So k is equal to k to the 5th power, because that's our power. That's it. And then again, radical, we got 3n. Our power is 5. It's going to be to the 5th power. Don't forget our parentheses. And it is cube rooted. Done. Yay, happy days. All right, now we are going to go into the simplifying. All right, if you need to take a break, but I'm going forward. All right, so it says simplify, use absolute value signs when necessary. So remember, we're using absolute value signs whenever we have square roots, right? When we're doing with square roots, 4th roots, 6th roots, not seeing a 6th root, but if we had a 6th root, hypothetically, we'd be using them, right? Because they're restricted. Remember, those are domain restrictions. They have to be positive, right? Just remember back to our graphs. What were the x's? They were always positive, right? We couldn't have like negatives, right? Our answers will never be negative. But with cube roots, don't matter. It could be anything. Just like in our graph, it went onto the negative side, right? The answers were in the negative side. So it's okay. So luckily for 23, we don't have to worry about absolute values. We're just gonna let it be. And honestly, for absolute values, you would just worry about that at the end. Okay. So let's take a look here. So I know that this is going to be, I'm just going to use a little factor tree here. So negative 54, I'm going to not worry about the negative right now. I know that 2 times 27, honestly, I didn't know it was 27. I had to do some calculations, right? But I know it's even, right? So 2 goes into, in your calculator, just go 54 divided by 2. I'll give you 27. And you're like, oh, that's the other number. Okay, I know 27, that's 9 times 3. And I know that 9 is broken down to 3 times 3. Honestly, if you were like at 27, you're like, ooh, I know the cube root of 27, right? And you'd be like, it's 3. Then that's fine. You don't have to go all the way down, okay? But if you're like, no, I like to see them, I like to do this, then go for it. So remember, it's a cube root, so I'm looking for groups of 3, right? So I have 3 3s, so which is good. So that's my perfect cube right here. And so that's the thing that's going to go on the outside. And for me, what I like to do, I like to write my answer like I just have to write the radical, and I know it's cube root, and I know this -7 is going to be on the outside. And I may add some things in here as I pull them out. So right now what I'm pulling out is that 3. So I'm going to go times 3, right? Because that the cube root of this 3 times 3 times 3 is 3. All right. And then, okay, and then this 2. This 2 is the only thing left. So that just gets left behind, stays in the cube root, can't go out because it's not a perfect square or a perfect cube. All right, now I'm going to look at the x's. Well, I have 2 x's, right? So it's x times x. And I know for sure I can't get a group of 3 with this. So this is a perfect square. So if this was a square root, I could take it out, but it's not. It's a perfect cube. I mean, it's a cube root. So we're looking for perfect cubes, which we don't have. So it's just 2 out of 3. So this stays inside. And then I'm looking at my y's and I'm like, okay, I got 7. And honestly, you don't have to draw these out. I just like to do it in class just because so you can visually see. So I have 7 y's. And I'm like, well, how many groups of 3 do I have? I got 1, I got 2, right? So that's 2 groups, right? So this is a perfect cube that comes out and another perfect cube that comes out. So I actually have 2 y's on the outside. So it's y squared. And I just have this 1 y left over that has nowhere to go. So it stays in there. All right. And so I'm just going to make this a little bit nicer. One thing I did not address, and maybe you noticed. Remember this was a negative. And normally if I can take out the negative, I will. Like you should do that. Okay. So what I'm going to take out instead is I'm going to take out, instead of a +3, I'm going to take out a -3. Because honestly, negative times negative times negative is still going to be negative, right? If I multiply that by 2, it's still going to be negative because that 2 is positive, right? The same would be true as if because you may ask, well, what if I put the negative on the 2, right? So -2 times 3 times 3 times 3, what does that equal to? Still -54. So honestly, it doesn't matter which one we make negative, but common practice has been that we don't leave the negative inside there. If we can take it out, we'll take it out. Okay, so here we go. So we're going to make these all -3s instead. Okay, so what we're pulling out is a -3. Okie dokies. So it's going to be -7 times -3, which is, let me do it with this color. So that's going to be +21 y squared, cube root of 2x squared y. Just like that. So I usually have my rough draft where I do all of my work and then I do my finalize and I pretty it up, right? Make it all pretty. Do we need to worry about the absolute values? Remember, I said we didn't have to, right? Because it's cube root. So we're good. All right, so let's do an even one and we'll do 25 and the rest of them I'll kind of just kind of do what I did before, it's just do a think aloud. So let's try to look at this guy. So outside here is our -3. So I'm just going to set this up like I did before. So I have my square root, my -3 out here. I'm going to leave a little bit of space because I know I'm going to hopefully pull stuff out. All right, so I'm going to have my, try to keep the colors the same. So 175, what goes into 175? Well, I know 25 does, right? Because 25 goes into, so if it's like $1.75, that would be like, how many 25 cents is that? That's like 7, right? Ooh, I know 25 is a perfect square. So I could just stop right here. What's the square root of 25? 5. So I could just say 5, just times 5, right? But if you're like, no, I need some more. So you could just go, 45 is 5 times 5. That's my group of 2. I told you it's a perfect square, right? And so that would go right here. And that would be this 5 right here. Okay. And then what goes inside is going to be the 7. Honestly, if you didn't have anything left, then you wouldn't write in and no numbers would go in here. right? But we have the 7 left, so we're going to have to write the 7 there inside the square root. And then we're going to look at the next variable, which is our u to the 4th power. So we have 4 u's. How many groups of 2 do we got? Got 1, 2. So technically what comes out is u squared, right? Not because we have 2 groups of them, remember? So a u comes out here, u comes out here, so it's u times u, which is u squared. All right, and what about our v? Looks like I'm running out of room. So we got v squared, and so we know that, v squared is v times v. It's one group, right? So we're just going to have a v outside here. And yeah, all we have left inside is 7. So I'm going to pretty this up a little bit. So this is going to be 3 times -3 times 5, which is -15. And this is going to be u squared v. And then that's going to be the cube, the square root of 7. Now, remember, this is square root, so we have to think about the absolute values. What has to have the absolute value? Well, the u squared is always going to be positive, so we don't have to worry about that. However, the v can't just be anything. So, well, it can be anything. We're just going to make sure that it always stays positive because we know that our square root's answer always has to be positive. So here we go. We're going to put in the absolute value right here. All right. That's it, because the square root of 7 is always going to be positive. That's the only thing that could potentially make this the wrong way. And some of you guys may wonder, well, this is a -15, so does it really matter? Yeah, because if this was a negative number, so this, in other words, since the root radical is always going to be positive and you're multiplying by the -3, this answer should always be negative, right? You see how this works? But if this v is negative, then it's going to cancel out this other negative with the -15, right? And then what's going to happen? We're going to get a positive answer. You can't have that. Doesn't make it. You can't do that. So that this is going to be right. That's why we need the absolute values in there. Okay, there we go. Now let's do some think alouds. Alrighty. So I'm going to set up my radical right over here. My rough draft right out there. And I know the -4 because that's already outside here. And I know, oh, this is the 5th root. So I know this is 8 times 8. And this is like 4 times 2, and which is 2 times 2. Just going to keep on going until I have like no more left. And I'm looking for groups of 5. And I think we definitely have a group of 5. There's 3 here, plus these 2 right there. So that looks like poop. I'm just kidding. So 2 times, so this is just going to be 2. So that's going to go right out here. I have my perfect 5th. And then I do have 1 that's left over. So that's going to be the 2. Notice I'm not using the 4 and the 4 because I've already used those up. I've already distributed those, right? Or factored those guys, right? So that those don't count. And then I'm going to look at the u. It's u. I'm looking for groups of 5. So I know if there's 8. Well, I know that there's 1. So basically I could go 8 divided by 5, which is just 1. So I could take out a u. How many do I have left over? 3. So, and then this is going to be, yeah, I'm not going to get a group of 5 from there. So that's just going to be v squared. Or I'm going to just, again, I didn't look at, the negative. See, this is why I need to check, right? So what we're going to pull out, just like how we did over here, and then pull out that negative. So that's going to be the negative there. So these are all -2's. All right. So there we go. And so that's going to be final answer is -4 times -2, which is positive 8u, 5th root of 2u cubed v squared. I don't need to worry about absolute values because this is an odd root. All right, moving on. Okay, we have I'm going to set up my 4th root here. And I got the negative on the outside. I'm just going to put like right over here. And 32. Okay, off the top of my head, I can't think, maybe 16. 2 times 16, right? That's 32. I know that 16 is a perfect square. So that's going to be the square root of 16 is 4. For those guys who would like to see that, there we go. And then my leftover right here is 2. So I'm going to put that right in here. And okay, no negatives there, so I don't have to worry about it. Yay. And then I'm looking for the x, right? I have 6 x's. I have 1 group of 4, so that means I have 1 group on the outside and then 2 left in the inside. So that's going to be x here and then 2 left here. And then a y, just y by itself. Yeah, that just stays in there. And does anything need to be absolute valued? Yeah, this guy right here. So it's going to be -4, absolute value of x, the fourth root of 2x squared y. All right. How am I doing on time? Are you still there? All right, let's see here. So for 27, we're gonna do a couple more. Again, I'm gonna just set up my square root or cube root right here. I have that -5 out here. And 320. Let's see, what goes into 320? 10 for sure, and I get 32. And then that's gonna be 2 and 5. And that's gonna be, oh, I just did 32, right? And it was 2 and 16. Right? And then I'm just gonna go 4 and 4. Honestly, I can just leave it at 4 and 4 because 4 and 4 is already, oh, nope, just kidding. We're using 3 of a kind, so yeah, I'm gonna just keep on going. My bad. So everything is primes, yep. So I'm looking for groups of 3. So I'm gonna be like, okay, here's one group of 3. Here's another group of 3, right? And then, so that's 2 of them. So 2 times 2, which is 4. So let me just times that by 4. And then I have just my 5 left over. Didn't miss anything else. There's my 5. Don't have a negative, so okay, good. I know I keep on forgetting those negatives. And then if you look at the H, if we're looking for groups of 3, 6 divided by 3 is 2. So I know I have 2 H's that come out, or 2 groups of H's come out, and I have no remainders, so it's just going to be that. And then J is going to be, there's 8 of them, so I can take one group out. I just have 3 left. So that's going to be J here. I'm going to try to squish it in. And then J to the 3rd power here, because that's what's left over. And 7, oh, that doesn't make sense. Why am I doing to the 5th root? It's supposed to be 3s, groups of 3, right? Because it's the 3rd root. So I have 8. So that's going to be 1 group, 2 groups, 2 groups, and then I have these 2 left over, right? Ooh, could have been bad. But I got a lot of emails after that one, hopefully. Because if I didn't, that means either you didn't watch it or you thought it was right. Sad days. All right, and then we're going to go to k to the 7th power. Right, we're looking for groups of 3, so that's 1 group, 2 groups, and then that one left over. I was like using my hands with these, right? So we have 2 groups, so it was k squared, and then we got just the 1k there. And now we're going to clean this up because this looks kind of like a mess. So that's -5 times 4, which is -20. H squared, J squared, K squared. And then this is going to be the cube root of 5J squared K. All right, a lot of things going on. All right, let's take a look at this one. So again, this is a square root. So I'm thinking, okay, we're going to have to use some absolute values, maybe, depending. So here it is. So there's my -5. Oh, maybe I should move this a little bit further away, give myself some room. All right, so here we go. So we got 448. Okay, I know 4 goes in there for sure, right? 4 goes into 4 once, 4 goes into 4 once, and 4 goes in 8 2 times. Yeah, quick division, right? And I know that this is going to be even, so I'm going to go, well, that's going to be 2. 2 goes in there for sure. 2 goes in 11 5 times with a remainder of 1. So 2 goes into 12 6 times. And 5 times 6 is 7 times 8, right? 7 times 8 is 56. And then 8 times, that's going to be 2 and 4, and 2 and 2. All right, that was a lot, but we got there. So we're looking for groups of 2. So we're like, okay, here's 1, here's 2, and this guy with this guy is 2. So that's 3 groups. And what do I have left over is this 7. I don't think anything else. All right, so here we go. 1, 2, 3. So 2 times 2 is 4. 4 times 2 is 8. So we're multiplying this by 8. And what's left over is the 7. All right, and then we're looking at x to the 4th. How many groups of 2 can we have? 4 divided by 2? X squared. Y, just y. There's only one y there. And z to the third power, well, that means I have one group of 2 and then one left over, right? So it's just going to be z, 1z. Remember, that means a group, right? And then a z in here. And it is square rooted. So we're going to just multiply those two guys. It's going to be negative 40 x squared z square root of 7yz. Ooh, do we need any absolute values? Okay, negative 40 is just negative 40. We're going to leave that. X squared is always going to be positive, so we're good. And just the z. That's z1. All right, there we go. We got to laugh sometime, right? How many more problems? Oh my goodness, I'm going to go die now. Okay, 42 problems. We're so close. All right, 29. I'm going to have to rethink it when I make these review problems, right? All right, serves me right, I suppose. All right, so this is 112. Oh, didn't I do a 112 here? Yeah, I did. So we can just copy this at 2 times 56. We don't have to copy it, we're fine. So, oh, I didn't set up my radical. So here's my radical, and that's the 3 on the outside there. And this is going to be 8 times 7, which is, and this is going to be 4 times 2 and 2 times 2. All right. So we're looking for groups of 2 here. So here's one, and here is the other one. And the 7 is left over. Usually 7s are left over. So this is 2 times 2, which is 4, and the 7 stays in there. And we got x to the 4th, so that's going to be 2 groups, right? Because 4 divided by 2 is 2. Oh, not in the inside, gets out. And the y, no pairs, so that just stays inside. So let me clean this up. So 3 times 4 is 12. X squared is going to be positive, so we're good. And this is just going to be 7y. So we do not need any absolute values. I'm absolutely sure. That's all we got. And our last one, ooh, just numbers, yay. So this is just going to be 10 times 100. And I know 10 times 10 is 100. I'm going to just, oops. I'm just going to stop right there because I know I have 3 10s and it's the 3rd power. Happy days, right? So I'm going to just, that goes all on the outside. It is negative, so I'm just going to be like negative, negative, negative. So it's going to be negative 5 times negative 10. Notice there's nothing else left, so it's just going to be 50. Yay! Done with this section. We only have 2 more sections left. That's it. Gonna die. It's okay. We're fine. We're all good, right? Gonna do math. Yay. Okay. So whenever we're adding, subtracting radicals, we need to make sure, just like we would with like fractions or like with adding, combining like terms, they need to have the same radical. We need like radicals, right? If you notice right here, these are not like radicals, but we can see if they are actually like radicals in disguise, right? So we're going to simplify like we've been doing. So 54, what times what is 54? 9 times 6. I blanked out for a second. 9 times 6. Oh, I know that 9 is a perfect square, right? So just like how we've been doing, I'm going to set up my radical right here. I know the 3 is on the outside, and my perfect square of 9 is, so the square root of 9 is 3. So we're just going to write that. So this guy right here is going to go right here because the square root of 9 is 3. And what do I have left is just the 6, right? The 6 would be divided into 2 and 3. There's no other perfect squares, so that's gonna be inside here. So this cleaned up is going to be 9 root 6. Okay, that's this part right here. Minus, we're gonna figure out this guy. Okay, well I know that 624 is 6 times 4, right? And I know the 4 is a perfect square, so the square root of 4. So here, let me write this again. So this 3 goes on the outside here, and the square root of 4 is 2, so it's times 2. All we have left is a 6. So notice right here, 2 times 3, that's 6. So we're just gonna clean this up here, 6 root 6. And then, okay, this is square root of 5. 5 is a prime number. We can't simplify this any more than that, so we're just gonna add that on. So now I'm gonna ask myself, well, Are there any like radicals in there? And you're like, well, yes, the square root of 6s. We have 2 of them. One here, let me highlight them, one here and one here, right? So these are my like terms, right? So I'm going to rewrite this as, so 9 square root of 6 minus 6 square root of 6 is what? 3 square root of 6 plus 3 square root of 5. This is my answer. There's nothing more I can do because they are not like radicals. That's all we got. All right. So yeah, that's what we're going to do for all of these. Okay, so again, right here, I'm going to simplify them. Oh, honestly, it's always good practice to simplify them, even though you're like, oh, they're both square root of 18. So if you want to add them together and then, actually, let's add them together and then simplify them, okay? Just because. So since they're both square root of 18s, right? So this can be negative square root of 18. This is plus 3 square root of 18. So that's going to be 2 square root of 18 minus, and then 2 square root of 24. Okay, now we know that the square root of 24, we've done this before, is 6 times 4, right? So I'm going to be like, okay, well, this is 6 times 4, which would be, we're going to take out this perfect square, right? It's going to be the square root of 4, which is 2. So let me see if I can get that. It's going to be 2 times this 2 right here. And then the radical 6, rad 6. Okay. And then this one right here is going to be, I know this is 9 and 2. What's the square root of 9? 3. So this is, okay, honestly, I'm just trying to, I'm just doing the shortcut way. But yeah, that's, 9 is broken down to 3 times 3, and that's my perfect square right there, right? So the 3 times 2 would give me a, so I'm going to write 2 times 3 square root of 2, all right? So I'm going to clean this up a bit. So this is going to be 6 root 2. And this is going to be minus, because it says minus, 4 root 6, right? These are not like terms because they do not have the same radical. Just leave it just like that. Yay. All right, we take a look at this guy right here, and we're going to see that this is going to be, okay, square root of 2 and the square root of 2, they're the same thing. But what about the square root of 8, right? So we're just going to simplify that one. And this is 4 times 2. We know that 4 is a perfect square, so square root of 4 is 2, right? So this is actually 2 times that. This is the 2, and this would become 2. And what do you have left? This 2 here. Do you see how there's a lot of 2's going on? And so literally we would be writing down, so this is a negative 3 square root 2 plus 3 square root 2 plus, this is 2 times 2 is 4 root 2. And you're like, well, doesn't the negative and the positive 3 cancel each other? Yeah, you're like, yep, pretty much. And all you have left is just the 4 root 2. That's it. Done. All right. Okie dokie. Now we're going to go with the cube roots. Well, we do the same thing with cube roots, right? Just like how we've been doing. So 135, I know it ends in a 5, so 5 times something. 5 goes into 13, 2 times, remainder 3. And 5 goes into 35, 7 times. Ooh, I know it's 27. 27 is a cube root. That's a perfect cube, right? So that's going to be, so remember the cube root of this is going to be just 3. If you don't believe me, just continue on, right? And so we're going to get, here's a 3, and that's from here. And then the cube root of 27 is just going to be 3. And what do we have left is the cube root of 5. Okay. And so if I know that 3 cube root of 5 is the cube root of 135, well, that's going to be the same thing here. So minus 3 cube root of 5, right? And then, oh, this is something else. So this is plus 3 cube root of 5. Okay, so remember, this is just equal to 9, right? I'm not going to rewrite it again. So if you look at right here, ooh, these cancel out. Do they always cancel out? No, they don't. It just happens to be these 2 in a row cancel out. So 9 cube root of 5 is our answer. Hopefully I'm doing these right. No, these are fine. Always, yeah, please make sure you check your answers, right? With the one, and if you have questions, let me know. All right. Here we go. So we're just gonna, this last one doesn't need to be simplified. We're just gonna simplify this guy right here. So this is gonna be 4 and 3. I know what the square root of 4 is, right? 2, right? So this is gonna be minus 3 times 2 square root 3. I'm gonna just put this down here. So this is a minus square root of 3. Over here, okay, we gotta do some work here. 24, well, 243. 243. I know 2 plus 4 plus 3 is 9. So this is definitely divisible by 9. So 9 goes into 24 2 times because that's 18. And we have a remainder of 6. So 9 goes into 63 7 times. Ooh. And then this is going to be 9 times 3. I got to keep on going. I don't care about cube roots or perfect cubes because it's to the 4th power. So I'm just going to simplify everything down to prime factors. And so I have a group of 4 right here. So it's going to be negative 3 times 3. You're getting that negative 3 right here. And then what do I have left is just a 3. So what am I going to get? So it's going to be negative 9 fourth root of 3 minus 6 square root of 3 minus square root of 3. Now notice, these are all 3's, but we can't add them all because that one's a fourth root and that one's a square root. Totally different, right? Think of them like different exponents, right? So this is all we're going to have left is negative 9 fourth root of 3, and negative 6 minus 3 is minus the square root of 3. Negative 6 square root of 3 minus square root of 3 is going to be negative minus 7 square root of 3. That's it. All right, let's put these two guys. Oh, look, this will save us some time. They're the same thing, but one's positive, one's negative. I'm just going to cancel them out. Let's do that. All right, we don't even need to do them. All right, and so we know that this is going to be 9 times 3 for 27. The square root of 9 is 3. Square root of 3. And then we have that negative right there. Yay, happy days. That's our answer. All right, now we have to deal with multiplying. Multiplying is way better than this one. This is insane, right? There's just a lot of simplifying to go on, right? But here, we're just going to, just like how with fractions, when we add fractions, you have to look for, common denominators and all that kind of stuff, right? You have to look, even like combining like terms, you're like, you have to have the same roots or same variable or whatever, right? When we multiply, don't even care. Don't care. All right, so same thing here. They're both in the only thing you need to care about is it inside the radical or is it outside the radical? All right, and so if they're inside the radical, you just multiply whatever's inside the radical. So this is going to be the square root of 2 times 2, which is 4, and x to the third times x, which is x to the fourth. I remember we add those exponents, right? And so we can simplify this. Well, what's the square root of 4? 2. What's x to the fourth, the square root of that? X squared. Everything's positive. We're good to go. Happy days. Life is good. All right. Outside, the only thing we have is a 3. So we're just going to multiply that. And then honestly, if you want to simplify first, then multiply, you can do that. Either way, I'm just going to multiply. So 10 times 3 is 30. And n squared times n squared is n to the fourth. And what do I notice here? 30 can be split up into 15 and 2. Yeah, and this can be 3 and 5. There is nothing that's the same or common. No perfect squares in here. So we're going to just leave it like that. But I do know that the n to the fourth power is the same as n squared on the outside, right? So this is going to be 3n squared, square root of 30. Yay, that's it. That's all we got. All right, we're down to the last 4. Are you ready for this? All right, so notice that these have parentheses in the first 2, right? Distribute. It's the same thing that we normally would have done. Notice this is on the outside of the radical. This is the inside of the radical, so we cannot multiply them together. All that's going to look like is 2n square root of 6n. That's it. Plus, now the square root of 6 times 6, which is 36, and n. All I'm going to do now is simplify, because I know what the square root of 36 is. It's 6. The one on the left is already simplified down. There's nothing else we can pull out. And they're not like terms, so you just leave it like that. do we need any, what is it called? Any absolute values? Because it says use absolute value signs when necessary. Ah, yes, this N right here, that N. Okay, and then right here. If we take a look at this, again, we're going to multiply it. We're going to multiply the 5 with just the 4. And the 4 doesn't go inside because, again, not inside the radical. So we're going to get 20 square root of 5x plus, now we're just going to multiply just the inside. So it's 5 times 5 times 5, which is 25, and x. Right? The left-hand side is already simplified down. But the right-hand side, remember the square root of 25 is just 5, right? So this is just like times the 5 out here, right? So all we're going to have left is 25 square root x. No like terms or no like radicals. Well, we can still say like terms. So we're just, that's our answer. Ooh, do we need any absolute value signs? No, x is on the outside, so we're good. Here we have, so -3 is on the outside. And I'm going to go square root of, go 6 times 3, which is 18, and b to the third times b to the third, which is b to the 6th, right? Not b to the 9th. We're not doing power to a power. We're just multiplying the bases. And so I can simplify this. I know that 18 is just 9 times 2. That 9 is my perfect square, right? So that square root of 9 is what? 3. So here you go. There's a -3. Times that by, what is this called? Times 3. That's this guy right here. And what's inside the square root? Oh, square root, which is 2, right? This guy right here, that's my 2. And then my b to the 6th power is going to be, 6 divided by 2, which is going to be b 2. So we have 3 of those, right? 3 groups. And no leftovers. So that's pretty much it. So we're going to write the answer here. So this can be -9, b to the 3rd, square root of 2. Do we need any absolute values? Yes, we do. Right here around the b to the 3rd, because b to the 3rd has the potential to be, negative. In the answer, if you looked, it does say this. So it's going to be -9b squared times the absolute value of b, square root of 2. It's the same thing. Okay. This is a more, I guess, more simplified version. They're being very, very picky. Yeah, I will accept either way. It doesn't matter. We don't need to get that picky about it, right? But this is a good answer as well. Probably a better answer, but yeah, we just take out whatever we don't need. Like the b squared is always going to be positive, right? So the only thing that we would need in there is just the b. So it doesn't matter. It's okay. Either answer is fine. Last one. We're there. How long did it take? Is it over this way? Whichever way. All right, last one is going to be -2 square root, and 15 times 10 is going to be, what is it called? 150. And then n cubed times n cubed is going to be n to the 6th. And I'm just going to break this down. Okay, I already know that 150 is just 15 times 10, because that's how I got 150, right? And I'm going to just go 5 times 3. This is 5 times 2. Do I have any perfect squares? Yes, right here, the 5 and the 5, right? These guys right there. And so what we're going to have is the -2. And this right here is 5 times 5, which is 25. It's the square root of 25. 5. And what do I have left over? Left over in the inside is 3 times 2, right? This 3 times this 2, which would be 6. All right. And then ends, I have 6 ends. How many groups of 2 can I have? 1, 2, 3. 3 of them. And no leftovers. So that's just going to be n to the 3rd power out here, because we've got 3 groups of them. So our final answer is going to be -10 n cubed square root of 6. And if we want to go with what the answer was saying, then we could write it n squared. So -10 times n squared, absolute value of n, square root 6. Or you could just go like this and be done with it. Either way is okay. All right. And that's the end of the Unit 4 review. Thanks for coming all the way to the end with here with me. And hopefully you don't have to go through it more than one time. But again, feel free to go back and forth, go with what you need, and we'll go from there. I'll see you later. Bye.